Hey, welcome back to Well, That's Interesting. The one of those days where we found something awesome, but we're not sure what it is exactly. Edition. Today is episode 243. This may be the smallest galaxy in the universe, and this newly discovered larva uses a face on its butt to infiltrate termite colonies. My friends, I'm going to need you to sit the fuck down and to strap in to avoid getting whiplash, not only because we'll be heading beyond the reaches of the Milky Way and then back down to Earth to crawl around in some dirt in Morocco, but from all the twists and turns these two discoveries take. We have been up to our craniums in breaking galaxy news lately, and it looks like it's not going to stop anytime soon either. For example, a few weeks ago, this past May, during episode 237, let's talk about Saturn's 128 newly discovered moons, and this teeny galaxy 1/1,000,000th the size of the Milky Way. We learned that just as with moons and planets, smaller galaxies can become ensnared into a larger galaxy's gravitational pull, resulting in those small galaxies orbiting the larger one. So yes, galaxies can orbit other galaxies, and it gets even cooler and cuter. When I say they're small, I mean it. What's called satellite or companion galaxies. They're usually fantastically tinier than their host. Eric Bell, senior author of the study we covered at the time, described their proportions best. Quote, "It's like having a perfectly functional human being that's the size of a grain of rice." End quote. Now, that is small, but we can do better. Back in late 2023, a discovery was announced and it caused quite an excited tizzy. A handful of stars, a wee 32,600 light-years away, might be the oldest star cluster on record, or it may be one of the smallest galaxies ever seen so far. Now, I can see the expression on your face from here. It says, holy shit. If it's a pocket-sized galaxy, I'm going to explode with fucking glee. But what do you mean it may be? What's the difference between the two? Well, excellent questions. For you see, some celestial bodies like Andromeda and our own Milky Way are hands down easy to identify as galaxies thanks to their size in light years, their size in mass, and their shape. Not to mention being jam-packed with a huge collection of gas, dust, and billions of stars. All of this is gravitationally bound and dominated by dark matter. The mass of the Milky Way, for example, is about 85% dark matter, which is, long story short, a substance that also makes up a significant portion of the universe, but unlike typical matter, it doesn't absorb, reflect, or emit light, making it virtually invisible. We only know it's there, whatever it is because of its gravitational pull on visible matter, and this doesn't keep me up at night at all. And if you also want to stare at your bedroom ceiling with a single teardrop running down your cheek, all you need to do is say to yourself out loud is that the universe consists of only 5% typical matter. 5%. 27% is this sweet, sweet dark matter. And the rest, a whopping 68%, is dark energy. Another goddamn mysterious force that scientists believe is causing the universe to expand at an accelerated rate. Anyway, back to defining galaxies and star clusters, which are somewhat the opposite of galaxies. They are gravitationally bound, but they're generally young, like for space, which means millions of years old. They're floating in a blob of gases, whose mass contains far less dark matter. But guess what? Things aren't always so black and white, and that's exciting. What I mean to say is that the line between galaxy and star clusters isn't always clear. Case in point, UMA 3/31, discovered way the fuck back in 2023, and to this day, it has astronomers flipping back and forth between these categories. In the first half of the show, we will meet the team that found this group of stars. We will run through the goddamn list of technologies used to analyze them, and we too will hop back and forth between how UMA 3/U1 qualifies for and doesn't qualify for either. Then after the break, we're heading to Morocco and checking out some butts. We will join lead study author Roger Vila. Sorry. A scientist at the Institute of Evolutionary Biology in Spain, and their team, who, although are hot for ants, discovered a never-before-seen fly larva. And boy howdy. Though the researchers found the larva to be part of the fly genus Rhynchomia, no other member of this group is known to do their kind of mimicry. And as you could tell by the title of today's show, it has to do with a facial feature in a particular place. But, no pun intended, but that's just the beginning. We will dive into the termite mounds the team dove into. We will see what they saw. We will sniff what they sniffed. But we will be left empty-handed at the end. You'll see what I mean. In the meantime, hi, I'm Jill Chacha, and if this is your first time listening, welcome to the flock, my rosy-cheeked business goose. To begin, I'm going to ask you to pack all your aloha and to join me in the old time machine as I dial it back just a smidge to 2023 and set the coordinates for the magnificent islands of Hawaii. I know, I'm stoked too. Now, it's here we'll be joining a team of astronomers led by the University of Victoria and Yale, and I'm going to be honest, on our to-do list is a task that is probably one of the most difficult goddamn things to check off in all of astronomy. We're looking for ultra-faint dwarfs, or UFDs. And I can see your expression from here. It says, Jill, for the love of God, we're in Hawaii. Why are we doing anything that doesn't involve a beach, and what the fuck is a UFD? Well, I'm so glad you asked. We'll hit the beach in a minute, but first, let's talk about a thing called UFDs. Ultra-faint dwarfs are a subcategory of small dwarf galaxies. And like that name suggests, dwarf galaxies are on the smaller side, meaning they only contain a few billion stars, and typically you can find them orbiting larger galaxies. And if that detail sounds familiar, you're exactly right. They're usually satellite or companion galaxies. Right the fuck now, we currently have around 60 known dwarf galaxies / companions orbiting the Milky Way. And please, hold onto your own globes because simulations suggest we could have significantly higher numbers than that. Somewhere between 100 to 500. Now, why they're so hard to confirm? Well, there's a few reasons. Although a few billion stars sounds like they're bright enough to be detected, they're not. Their faintness makes them blend into a background that is already blinding. And to make things even more difficult, dwarf galaxies are even more diffuse than larger ones, meaning those few stars are more spread out. Matching a gravitationally bound star to its proper dwarf galaxy can take time. This sounds like a pain in the ass, I know, but good news. We're looking for something worse. Ultra-faint dwarf galaxies contain a few hundred to 100,000 stars, making them the faintest galaxies in the universe. We only know of about 100 confirmed cases. That's it. Now, you may also be wondering why in the holy hell we're banging our heads against the wall to find them. Well, there's a pretty good answer. Remember in the intro I said galaxies are dominated by dark matter? Well, a UFD puts the Milky Way's 85% to absolute shame. If you can find an ultra-faint dwarf galaxy, you're going to find an even larger concentration of dark energy that can be studied. UFDs have 1,000 times more dark matter than their luminous matter. And it's all in one place, all in one sweet little package. So if you're hot for astrophysics, like the team from University of Victoria and Yale, one UFD could contain a bonanza of elusive answers into what the fuck dark matter actually is and how it works. So how are we going to find these things? We're going to need the big guns. So join me, will you, back atop Mauna Kea, a 13,800-foot dormant volcano located north of center of the Big Island. It's here we'll be firing up a good friend, the Canada-France-Hawaii Telescope, or the CFHT. Back in episode 237, we learned that this beast of an observatory sits at the highest point of all the islands, providing the clearest view, and has itself a 12-foot optical and infrared telescope. It's one of the largest in the world. Now, when you add this power with the likes of the Panoramic Survey Telescope and Rapid Response System, aka PAN-STARRS for short, located on Maui, girl, you've got a 1-2 punch of observing the infrared and inhaling huge amounts of data. PAN-STARRS is basically a computing facility that surveys the sky for moving and variable objects on a continual, unblinking basis. And if that sounds impressive, it is. For example, in January 2019, PAN-STARRS recorded 1.6 petabytes of info, which is a fancy way of saying it was the largest volume of astronomical data ever released. So my friends, this combo is so fucking powerful, astronomers call it the collaboration of collaborations. It's like if DC and Marvel joined forces to create a new group with a new name, which may have happened, but I don't care, so I didn't look it up, but that's what it would be like. This real-life superpowered situation is called the Ultraviolet Near-Infrared Optical Northern Survey, or UNIONS for short. And I can see the comic book cover now. There are so many glasses. To no one's surprise, UNIONS found something. And that's about as definitive as we can get. It looks like UNIONS overachieved in finding what could possibly be the smallest, faintest galaxy in the universe so far, or an extraordinary tiny star cluster that's not like any other cluster. Let's get into it. First, special shout out to the folks over at Keck Observatory's Deep Imaging Multi-Object Spectrograph. Hey, they confirmed our new discovery is gravitationally bound, and thus either of the categories. And second, please, if you will, grab some paper and draw a line down the middle. Go ahead, don't be shy. Okay, now on one side, I'd like you to label that column, "Shut Up, It's a Galaxy," and on the other, name this column, "Nope, It's a fucking star cluster." Now, what we're going to do is go through the list of characteristics of this new discovery. If the characteristic belongs to galaxies, please file it under "Shut Up, It's a Galaxy." And if it falls under star clusters, you know what to do. Add it to the column, "Nope, it's a fucking star cluster." At the end, we're going to see which list is longer than the other and by how much, all to make a determination, if any. Sound good? Great. My friends, it is my honor to introduce UMA3/U1, and it's practically within arm's reach for space, at about 30,000 light years from the sun. And with that same arm, you're going to want to squeeze its cute cheeks because it's only 20 light years across, contains only about 60 stars, and has a visible mass of about 16 suns-ish. That is wild. But it gets crazier. And it will continue to do so, but I'm getting ahead of myself. We also know that it's been around nearly since the beginning of time. These stars are 11 billion years old. This thing barely exists, size-wise, but it's been existing for basically forever. So what is it? As reported by Brian Koberlin of LiveScience.com, in a recent study, the team performed several tests to distinguish whether UMA3/U1 was a star cluster or a dwarf galaxy. Their first approach was to look at the dynamics of the visible stars, assuming it's a star cluster. Based on their known motions, the team simulated how long it would take for the stars to break free and form their own systems. And this can happen via a chance encounter with another star acting as a gravitational slingshot, with the result of it gaining enough speed to escape. This process is known as evaporation. Based on their clickety-clacks, UMA3 could survive another 2 to 3 billion years. That's a good fraction of the estimated 11 billion year age, which suggests it's simply a stable star cluster. End quote. So, here we are. Add slingshot or evaporation to "Nope, it's a fucking star cluster." In the next test, the team calculated something else fun called mass function, and this provides a visual of how mass is distributed within different areas. If it's a cluster, then the mass should be more evenly distributed through its blob of gases. But if it's a formed galaxy, the star should be kind of all towards the center, where a possible black hole would be. So, what did they find? Drumroll, please. Thank you in the back. Neither. They found no answer. The distribution of UMA3 U1's visible stars is only okay. It's only like an okay match to clusters we've seen before. And if we're looking at it as a galaxy and comparing it to other galaxies, the central stars, the one in the middle-ish, well, they should be the oldest, and thus white dwarfs and neutron stars, but they are so dim that the researchers can't see them clearly, and they can't make a determination. So, no winner here. Let us shrug and move on to a statement from Yale University graduate student Will Cerny, and second author of the study we're poking right now. This is a statement they said to keckobservatory.org, quote, "How these stars have managed to stay tight-knit is remarkable. One possible explanation is that dark matter may be keeping them together. The object is so puny that its long-term survival is very surprising. One might have expected that the harsh tidal forces from the Milky Way to have ripped the system apart by now, leaving no observable remnant. The fact that this system appears to be intact leads to two equally interesting possibilities. Either UMA3/U1 is a tiny galaxy stabilized by large amounts of dark matter, or it's a star cluster we've observed at a very special time before its imminent demise." End quote. So, will the Milky Way's big disk energy shatter UMA3/U1 because it's a mere cluster? Will it keep calm and carry on because it's being held together by a force so powerful and yet unknown it keeps me up at night, and thus a galaxy? Will we ever know? To answer these questions, more observations need to be made. So please, hold on to your chart. Keep it safe for next time. And in the meantime, UMA3/U1 will continue to have two names to identify its ambiguity. Yes, this abbreviation stands for two things don't tell conservatives. If it's a dwarf galaxy, its name will be Ursa Major 3, as it was found in the constellation Ursa Major, so UMA3. If it's a cluster, it'll be named Unions 1, since it was the first cluster discovered by Unions, so U1. But we're not sure, so it has both names for now, proving once again, nature's kind of gay. After the break, we are moving on from tiny celestial bodies to tiny larvae, but we're sticking with mysteries. We're about to meet a fly with a lot of tricks up its butt and even more secrets. Next. Stay tuned.
Hey, it's Paris. You know I love sparkly things, right? Like stars. Duh. And thanks to Hilton and AutoCamp, I just slept under them. Picture me serving looks by the fire outside my luxurious Airstream, making s'mores with the kids, while a national park is our backdrop. The great outdoors meets Hilton hospitality. That's hot. Explore all the new ways to stay at Hilton.com. Hilton for the stay.
The McDonald's Snack Wrap is back. You brought it back. Ranch Snack Wrap. Spicy Snack Wrap. You broke the internet for a snack. Snack Wrap is back. Ba-da-ba-ba-ba.
And we're back. We are so back. And my friends, please swap your thongs for a sun hat because we're leaving the lush mountains of Hawaii for the equally beautiful yet bright arid mountains of the Anti-Atlas Range in Morocco. And for my fellow geographically challenged Americans who may be wondering why we would do such a thing and where we are exactly, don't worry, it's worth it, and I got you. Please, everyone, imagine the continent of Africa. Thank you. Now point to the very northwest corner. Perfect. There is Morocco, whose shape kind of resembles a forward slash. If you circle the bottom third of that slash, you've got yourself the Anti-Atlas mountain range, which, major fucking fun fact, formed 300 million years ago when North America, Europe, and Africa slowly collided into one another. And get this, that collision also formed the Appalachian Mountains. So this range in what is now North Africa and the range in what is now the United States were once connected and are basically the same stuff. There's something symbolic about that, and things are only going to get way cooler from here. So please, join me, will you, here in the Anti-Atlas Mountains with Roger Vila of the Institute of Evolutionary Biology and lead author of the study we're squirming into right now, members of the Consejo Superior de Investigaciones Científicas, nailed it, and great, now I screwed this one up, and Pompeu Fabra University, who, back in 2024, were having a bit of trouble thanks to the weather. Despite that, they nerdily persevered, and it paid off big time. As Roger explained in a statement to the Institute of Evolutionary Biology website, quote, "In our research group, we mainly study butterflies and ants. As it had rained, a lot of the butterflies were not flying, so we looked for ants. When we lifted a stone, we found a termite mound with 3 fly larvae that we had never seen before. The water had probably flooded the deeper layers of the nest, and the larvae had emerged into the surface." End quote. Well, my friends, this totally chance encounter led to the discovery of a brand new species of blowfly whose physiology, behavior, and hacking skills have never been seen before. Let's get into it. Please drop whatever bullshit you're holding right now and pick up your phone. Head on over to today's post over at the old social medias and swipe through until you see the fake face of a little larva. But don't worry, it's actually kind of cute. Yeah, you are absolutely right to think that those 2 beady dots are eyes, and that this is a head with antenna. If you thought that, you're not the only one. Thousands upon thousands of harvester termites think the exact same thing. But that's no face. In fact, that's not even the right end for a face. At the ass end of this larva is what researchers call a termite mask, which so resembles the physical features of the actual termite's head, it's basically art. Now, if you swipe through to the next several images, you'll notice a few things, like how, boy howdy, that ass is spot on when compared to its non-nestmates, but how the rest of the larva, its body, it looks absolutely nothing like a termite. This thing is long and plump and covered in additional air quotes antenna. This face is in no way the only thing that's allowing this larva to get away with termite fraud. So what the hell else is going on here? In a desperate attempt for additional samples, the team, quote, made 3 more expeditions in that area, and despite lifting hundreds of stones, found only 2 more flies together in another termite mound, end quote, Roger said to the IBE website. Well, with literally a handful of this rare new species, the team ventured back to the lab where they'd meander through some DNA samples, run tests from fake face to real face, and observe the larva's behavior when placed in a makeshift termite mound. What was revealed was downright eerie and brilliant. As reported by the Institute of Evolutionary Biology website, by using scanning electron microscopy for the close-up of all close-ups, the larva's unusual tentacles around their bodies were found to mimic termite antennae in such exceptional detail that when touching them, termites basically felt like they were looking in a mirror. Here's what I mean. Like our bee friends, inside the nest, it's basically pitch black. So termites recognize each other via their antenna first by detecting the shape. Being so long and plump gives away nothing when you're covered in these masterpieces. So when a termite feels up a larva, it's probably thinking, hey, this is just another termite's head. But it doesn't stop there. There's a 3rd layer that makes this deception a complete success. Scent in a cramped, dark nest is the primary language. According to IBE, all members of a nest share an identical scent, and soldier termites attack and dismember any stanky intruders from other colonies. To survive, this larva needs to be wearing a cologne with the same chemical makeup of a completely different creature. And guess what? It is. My equally fragrant business goose, please take a look at the illustrated graphic over at the old socials. In it, you'll see an artist's rendering of the two creatures side by side for comparison. And there's also an extraordinary graph that includes two lines that resemble a heartbeat. Those are no heartbeat. The top line is the scent signature of the fly, and the bottom, that of the termites. What do you see? I'll give you a sec. Yeah, if you said they're exactly the same, you're not exaggerating. Quote, "We quantified the chemical composition of these larvae, and the result is surprising. They are indistinguishable from the termites in the colony where they live. They smell exactly the same. In addition, the larvae and termites in a particular colony might have slight differences in their chemical profile that differentiate them from other termite mounds. This odor is key to interacting with the termites and benefiting from their communal lifestyle. It is a chemical disguise," said the amazed Roger, to IBE. So, not only does this larva mimic the face and the antenna of a termite, it can reproduce the hyper-specific scent of a particular termite colony, the one that it's in. So one might ask, why go to such lengths? It turns out, it's to get fucking pampered. Once in the lab, Roger and the gang observed that the fly larvae made a beeline to the most populated areas of the nest, where they received constant attention from the termites. They preened them, they passed them food from their huge reserves. Are you jealous? I am, and you should be. But you're about to be frustrated as well, because the 5 larvae that the team studied eventually died without metamorphosizing, suggesting that there might be elements of the nest and the symbiotic relationship between these termites and the flies that the team was unable to transfer to the laboratory. So their full diet is currently unknown, and their adult form remains a mystery. Thanks to DNA sequencing, though, we know that this talented fucker is a part of the genus Rhynchomia, which has about 370 species. But none of them do what this one does. Oh, also surprising, those 2 beady dots on its ass face, those are actually its nostrils. Weird. And thank you for listening, rating, subscribing, telling your friends about what could be the smallest galaxy in the universe. It's so fucking teeny, but it could also be the oldest star cluster. It could be, who knows, but it has both names, and it's totally accepted. What a fucking marvel that is. Talk about this ass face. And a smelly thanks to the folks over at Airwave Media, the podcast network to which WTI belongs. If you love this show, and you do, you love the other podcasts in this family, then please stay interesting.